You cut your calories, hit the gym, and finally watch the number on the scale go down. But when you look in the mirror, that stubborn layer of belly fat hasn't budged an inch. Standard nutrition advice usually points to a simple math problem. We're taught that all body fat is passive storage, just excess energy sitting quietly in a vault, waiting for a calorie deficit to burn it away. But the fat deep inside your abdomen follows a distinct biological logic. It functions as an independent organ, pumping out a continuous stream of hormones to protect its own mass. Because it actively defends itself, a simple energy deficit triggers a localized panic. When calories drop, visceral fat responds by locking down and resisting breakdown. To force this tissue to shrink, starvation isn't enough. You have to introduce specific biochemical signals to bypass its defenses. The primary defense mechanism keeping visceral fat intact is chronic inflammation. It relies on a localized, inflamed environment to maintain its structure and resist your metabolism. We can dismantle that environment by introducing highly concentrated omega-3 fatty acids, found abundantly in fatty fish like salmon and sardines, along with walnuts. These omega-3s act as biological coolants. Circulating into inflamed fat tissue, they neutralize stress signals, keeping cells rigid. Clinical observations show introducing these polyunsaturated fats over 12 months shrinks visceral fat mass, even if overall body weight remains unchanged. Walnuts add a secondary layer of control by elevating satiety hormones like leptin, signaling your brain to stop craving food before restriction feels like a punishment. Extinguishing the inflammation strips the fat tissue of its primary armor. It becomes metabolically unstable, making lipid stores fully accessible for your body to break down. But inflammation is only half the battle. Your liver acts as the ultimate gatekeeper, and when it overproduces glucose, visceral fat is forced to expand to handle the overflow. To shut down that excess production, we need a potent plant compound called sulforaphane, most densely found in raw broccoli sprouts. These young sprouts contain 20 to 100 times more sulforaphane precursors than fully grown broccoli, delivering a concentrated dose in a single handful. Once digested, sulforaphane activates an internal control center called NRF2. This sends a direct physical stop signal to your liver, instructing it to halt the excess output of sugar. With excess liver production paused, we repair insulin sensitivity using high-concentration dark chocolate, specifically varieties with 85% cacao or higher, which are loaded with antioxidants called flavonols. We can compound that effect by adding chia seeds. Their dense soluble fiber feeds specific gut bacteria, which in turn produce short-chain fatty acids like butyrate. These flavonols and butyrate molecules both target the insulin receptors on your cell walls. They neutralize the local inflammation that usually blocks these receptors, allowing insulin to successfully dock and move sugar into your muscles for fuel. Halting the liver's glucose output and repairing insulin sensitivity effectively cuts the supply lines. Without that constant influx of excess sugar, visceral fat has no raw materials to grow. Even with defenses down and supply lines cut, your body still needs an explicit command to incinerate the fat it has already stored. We can deliver that command by consistently consuming extra virgin olive oil, blueberries, and Greek yogurt. These foods share high concentrations of polyphenols like anthocyanins, which activate the AMPK pathway, your body's master energy sensor. When triggered, it reroutes excess energy away from fat storage, forcing your muscle mitochondria to pull in those calories and incinerate them as heat. Flipping this energy sensing switch overrides your body's default tendency to hoard calories, ensuring that fat burning happens automatically at the cellular level. This is why the math of weight loss often fails in the real world. Two people can eat the exact same 2,000 calories, but depending on the quality of those calories, their bodies will process that energy in different ways. Destroying belly fat requires using food as biological data. Every meal delivers a specific set of instructions to your liver, your gut, and your fat cells. A calorie deficit will always be the baseline requirement, but it is the strategic addition of these specific biochemical signals that actually forces the stubborn fat to yield.